Hello, and welcome to the Servicing and Maintenance module. For this module today, I'll be going over some of the tools that are available to run and maintain your storage node. We'll start with talking about some of the monitoring tools available. So why do we even need monitoring tools? Well, as with anything in life, nothing ever goes smoothly, right? There are going to be issues that you run into, or you over-provision on hardware and need to re-optimize. And you can't re-optimize if you don't have any metrics or statistics to track the many phases of sector sealing involved with Filecoin. Which leads us into the next section of what do you even need to monitor? Well, as I just mentioned, the sector sealing pipeline, for instance. You can't re-optimize or troubleshoot if you don't have any insight into where your bottlenecks are, for one example. It is also recommended that you have tools to monitor your resource utilizations. This will allow you to detect if you have over or under provision on a certain aspect of your hardware. When, and not if, one of your servers has a process that kills itself, you'll be able to quickly detect that it simply ran out of RAM instead of spending days to figure out that otherwise. Finally, it is extremely important that your wallet balances are tracked, and not just for accountability reasons, but also in case your control wallet balance starts to go low. If one of these control wallets ever completely runs out of fill, your entire sector sealing pipeline comes to a grinding halt. There will be more on the different types of wallets in the upcoming wallet setup module. Here are some of the general options that are available to help monitor your storage node. You can use a blockchain explorer, which is just a website that pulls information from the blockchain. Some examples of this are Filefox, Filescan, or Filscout. There are also the traditionally used open source software applications, such as Grafana, which is a great dashboard application, or Prometheus, which is a time series database, great for tracking information over time. Since the Filecoin community has such a large software development backing, there are a lot of open source applications available, such as Farcaster, a pre-built Grafana dashboard with all of the metrics and information gathering already taken care of. Or SidGravity, a deal filter that can help manage your storage and retrieval deal pricing and other configurations. Another consideration is that you can always have your software development team make their own scripts and automation processes. This will allow you to create processes that monitor or track exactly what you need to. Next up is IPMI, the Intelligent Platform Management Interface, which comes built in with any enterprise-grade hardware. And finally, you can always use general Lotus CLI Commands, which can be extremely useful to monitor your storage node. In this section, I'll be discussing the IPMI tools in greater detail. The IPMI port will also need its own cable and IP address in order for you to access its interface, usually the form in the web GUI. There are numerous features that the IPMI tool provides, and I'll be going over some of them now. The first feature that I want to talk about is the ability to monitor your hardware's temperature. In the screenshot on the left, the temperatures of the different RAM slots and CPU are being recorded, and there's a line graph of any changes on the right to indicate if there are any sudden spikes in heat. It is important to monitor temperatures because, as with any server, high temperatures will destroy your servers, and Filecoin sector sealing is a very computationally demanding process. One of the features that IPMI can support to combat high temperatures is by controlling the fan speeds on the server. In this sample screenshot, the line graph shows your fan utilization percent in correlation with a specific temperature, which is configured on the right. For example, as the heat of your server increases from 40 degrees Celsius to 60 degrees Celsius, the fan utilization will automatically rise from 50% to 90% in order to combat the increase in heat. If the temperature rises too high for even the fans to handle, you can just shut off the server with the IPMI tool. I'm mostly kidding on this. In this sample scenario, it would be better to stop the processes that could be making your server overheat, and powering it off should be a last resort. The IPMI tool has the functionality to remotely power off a server, which is extremely convenient if the terminal or OS is unresponsive, or if the server is physically hundreds of miles away from you in another state or country even. It is important to note that this is different from powering down a server from the command line, which is often safer, as the command line shutdown allows for processes to come to a stop properly, whereas the IPMI is a forced, immediate shutoff. On the topic of remotely accessing the server, the IPMI tool usually has the feature to completely control the server remotely. Besides some latency from connecting over the network, you are able to access the server as if you are physically connected a monitor, which can be extremely useful. For example, when troubleshooting processes and applications that are not command line heavy. And finally, the last feature I want to mention is the event log, which just tracks every single event, error, or alert. For example, it will track anything from removing the lid from the server chassis to the times one of the redundant power supplies went offline for any reason, and even each time a RAM stick makes a calculation error. Now, onwards to some Linux CLI commands. In the next few slides, I'll briefly go over some examples of commands you can use to check your hardware status. The free command checks the amount of registered RAM and how it's being used. The cat command displays the content of a file, and in the sample screenshot, it displays all of the partitions on the server. The NVMe list lists all of the NVMe drives on a server, and finally the df command shows the mount point for these partitions. Next, we have ls-cpu, which displays the generic CPU info, such as the model or the CPU core information. And we have the htop command, which is useful for tracking all of the ongoing processes that are running on a server and how they are impacting the CPU. Htop can be useful in determining if you have too many or too little sectors running in parallel on a server. There's also the dmidcode command, which has its own suite of commands to check many different aspects of a server, such as the memory and processor, just to name a few. It is important to note that this command will cover different information than the commands covered for RAM and CPU in the previous slides. And finally, the iotop command checks all of the ongoing writes and reads occurring on a server's drive, which is useful to see if your drives are keeping up with the amount of data that they are expected to process. The tail command is useful to monitor any log files that you might have set up to log the output of your Lotus processes, and the watch command, in conjunction with some of the Lotus commands, can be extremely useful to monitoring your storage provider node. Speaking of Lotus commands, in this final section, I will briefly cover a few Lotus CLI commands that can be used to help monitor your storage node. One of the most important commands is the Lotus miner info, which displays a ton of information about your storage provider, such as your power on chain, general fill amounts in your wallets, sector status and the total counts for each status, and any storage or retrieval deals that may be ongoing. Combining this command with the watch command mentioned previously is a simple but effective way to start off with monitoring your storage node. The combination of Lotus Miner proving info and proving deadlines can be used in conjunction to display upcoming window post deadlines, which is useful to prevent any other processes from competing for hardware resources during this crucial period of time. And finally, there are a plethora of other commands like the wallet list and the actor control list that displays information about parts of your storage node that you might need to know. And that's it. If you have any questions, please feel free to leave a comment.